Assalamu alaikum, dear students. Here we are and for your chapter number 13, Gravitational Fields. And of course, we are dealing with A2 Physics of 9702. Uh, Here you have two learning outcomes of this lecture. Number one, one is the understand that a gravitational field is an example of a field of force, and define a gravitational field of force and define a gravitational field as force per unit mass. The second point or the second learning outcome is represent a gravitational field by means of field lines. So these three basic points we have to discuss during this lecture. Now we will start our discussion from this basic concept of force. So as far as the force is concerned, of course, what is the definition of the force? According to Newton's first law of motion, you know that uh, Newton's first law of motion is telling you a body in motion remains in motion, and a body at rest will remain at rest unless an unbalanced force acts upon the body. So from the first law, Newton's law, you can determine or you can define the force. So how we can define the force? In this way. This is the definition of the force, the bacha wala definition, which you know that the force, the push or pull. So here we are actually defining the force in a proper way. The force is the agent which moves or tends to move the body at rest, or stops or tends to stop a body in motion. So this is the proper definition of force. So you know that force is an agent which moves or tries or tends to move the body at rest, or stops or tends to stop a body in motion. Basically, in one of the discussion of chapter number 2, lecture number 2, I have discussed the rest and motion, and here you have the detail of this discussion. But for the time being, I am moving forward, and this is what we have. Force is the agent. Now remember one thing, that you cannot see the force, but you can see the effect of the force. And if you are applying a force, the body is moving, so nobody can see the force which you are applying. Suppose this is a box somewhere here you have, and you are applying a force on this body. So you, of course, people can see you, but people can also see that this box is moving. But what is the force? Where is the force? People cannot see. So this is something which is very important as far as the force is concerned. So we use the term force is the agent which moves or tends to move the body at rest, or stops or tends to stop the body in motion. So this is very important to remember. Here now we are discussing two types of forces. One type is the contact force or contact forces, a force that is applied by objects in contact with each other. Like suppose here you have the example of reaction force, the tension or the friction. You know that if you have a body and you have a rope, suppose, and another person is here, and these two persons are pulling this rope towards each other. So the force of, say, person 1 is F1 onto F2 or onto the person 2, and here we have the person 2. The force of this person onto the person 1. So here we have these two forces. So what we can say, that this force F21 is a sort of tension for the person 1, and force F12 is a sort of tension for person 2. So there are number of examples of tension. Like suppose here you have a situation that a body is hanging with the suppose a cord, then weight of the body is acting downward, and if the weight is not coming down, or if the body is not coming down, so it means that there will be a force in the upward direction in the rope which is balancing, or which will balance the weight of the body, and this force is termed as the tension. So this is something which you already know, and we have discussed these things in your AS physics. Similarly, you know that we have friction between two bodies. When two bodies are in contact, then we have the frictional force. This frictional force may be the air friction or surface friction and so on. But basically, all of these type of forces are termed as the contact forces. On the other hand, we have another type of forces termed as the non-contact forces. So what are non-contact forces? So this is very important. You know that there are some situations where forces that act between two objects that not physically touching each other. Then suppose you have a situation of a very you can say a very common example here. Suppose you have earth and a body is falling towards the earth. So what you will say, that the force of attraction of the earth on this body, which is the gravitational force, is sort of non-contact force, or is example of non-contact force, because these bodies, yani mass m and earth, they are not in contact, but still they are you can say attracting each other. They are applying the force on each other. The forces they are applying on each other we will discuss in detail later on, but for the time being we know one thing, and this fact is that these two bodies are not in contact, physical contact, but still the mass m is moving towards the earth. It means that a force is coming from the earth, and this is nothing but the gravitational force. And gravitational force, you can say, is a type of non-contact force or forces. Similarly, you know that if you have two charged bodies, like if you have one positive charge and one negatively charged body, then they have a force of attraction, and this force of attraction again is termed as the force which is non-contact force, because these two charges are not touching each other, but still there is a force of attraction. And this electrostatic force is simply, you can say, is another example of the non-contact forces. Similarly, you know that if you have the situation of a magnet, so if you have north and you have another magnet, suppose you have south here, so there will be a force of attraction again. And if you have this situation of north and north, then you know that there will be a force of repulsion. But whether it's a force of attraction or force of repulsion, but the main point is that they are applying force or forces on each other, but you know that they are not physically touching each other. So all these conditions, all these examples are examples of non-contact forces. Here, as you know that the chapter we are dealing is the gravitational fields. So our focus will be on this force, which is the gravitational force. So this is something which is very important to know, that the gravitational force is the non-contact force. As we are discussing the non-contact force, so we have a concept of a field of force. Yani there is a new concept. Yani if you have two bodies and they are applying a force of attraction or repulsion, so it means that there is something which is around these two bodies, and that something is the field of force. This is called as field of force. So what is the field of force? So how you will define this field of force? So simply you can say that the region or of space surrounding a body within which it can exert a force on another similar body not in contact with it in terms of is termed as the field of force. Yani when two bodies are not touching each other, you have two masses, say body A and body B, and you know that there is a force of attraction between these two bodies, which is termed as the gravitational force. So GF or gravitational force is the field of force. So this is field of force is basically the area or the region where you have the gravitational force. So this is very, very important. And remember this thing that here we have mentioned another thing, similar body. Yani if you have a mass here, then this will be a mass. So these two masses are attracting each other. So the gravitational field you have in between them and the region of space surrounding a body within which it can exert a force on another similar body not in contact within it is termed as the field of force. So this is very, very important. And as I have already mentioned, you can emphasize on this point that the gravitational field is a field of force. So this is a very, very important, that gravitational field is one of the example of field of force. Now the point is, the gravitational field of course is a region of space around a mass within which another mass experiences a force of attraction. So after defining this field of force, specifically if we are talking about the gravitational field, then we can define the field in this way. The gravitational field is the region of space around a mass within which another mass experiences a force of attraction. So this is very, very important thing as far as the definition of the gravitational field is concerned. Now here you know that very easily you can understand this point, that if you have, like suppose if you are considering for the time being, as our focus is gravitational field, so for the time being I am just taking the example of Earth. So if you have Earth and the Earth is attracting a mass m, suppose, then what will be the gravitational field strength? So this is very, very important term. Gravitational field strength is basically the force per unit mass. Remember this definition, they will ask this in your exam. The force per unit mass in a gravitational field is termed as gravitational field strength. We represent this gravitational field strength by G. You know that if you are close to the surface of the Earth, G is 9.8, the acceleration due to gravity is 9.8, acceleration due to gravity is 9.8 meter per second square. But as soon as you will talk about the acceleration due to gravity, you have to recall that there must be a force which is producing this acceleration. So the force per unit mass, and if you have a mass of 1 kg, then what you can say, that here we have the gravitational field strength at one point, and what will be the equation? So simply you can write in this way, that gravitational field strength is simply given in this way, that is the force per unit mass, and here we are using G for this force. So this is very important to remember, that here we have the gravitational field strength, representation is G, and you know that we have been using G for the acceleration due to gravity as well. So remember this thing, that this acceleration due to gravity is because of a force which is gravitational field strength, and this force or you can say is 9.8 per kg. If this force is 9.8 Newton per kg, then the acceleration this force will produce will be 9.8 meter per second square. So remember this thing, that here we have this formula which is G, mass, force, acceleration. But as I said, that the gravitational field strength, and how you will differentiate, because both of these symbols are G. So the unit will be very important. When the unit is Newton per kg, you will have this understanding that you are talking about the gravitational field strength. But when the unit will be meter per second square, this will be the unit of a g, and this is something which is the acceleration due to gravity. So be careful. Even this equation, you have g is equal to f over m. So if you will rewrite this equation, you can write in this way that f is equal to mg or gm. So basically you can recall that the second law, Newton's law, shows that or gives us that f is equal to ma. It means that basically a is nothing but g, the acceleration due to gravity. But as I said, that if the unit of g is given as Newton per kg, so immediately you will get this idea that you are talking about the gravitational field strength. Gravitational field strengths. So I have mentioned here that the value of the gravitational field strength on the surface of the earth is 9.8 Newton per kg, which produces an acceleration due to gravity of 9.8 meter per second square, where if you have, of course, a body of mass 1 kg. So this is very important term, and inshallah we will discuss this term in detail. But for the time being, this equation and of course the relation of this equation with the acceleration due to gravity you should know, and this is something which will lead us towards the detailed discussion of g, where the g is you can say decreasing, where the g is increasing. If we are going away from the earth, what is happening? If we are going into the earth, what is happening? And then we will decide ultimately that what is actually the cause of this gravitational force, and from where this gravitational force is coming. So this is another very important question. Inshallah, in the coming discussions we will discuss this point as well. But for the time being, here we have another point to remember, and this is the representation of gravitational field by means of gravitational field lines. So you know that when you will talk about the gravitational field and you have a space, so how you will represent it? So what you will do, like here you have suppose the earth and you are dropping suppose a ball, then what is the use, or for what you are using this ball? So simply you can say that we want to determine the direction of the field, and we want to determine the force on any force on the ball is giving you the gravitational field strength, and what is the direction of the gravitational field. So there are two things. One is that as far as this gravitational field is concerned, you know that force is a vector quantity, so we use the term the vector field. I'm just using this term because you will see this term somewhere, but of course for the time being you need not to remember this term very much, but if you can, I think this will be another helpful term, vector field. Why is a vector field? Because the field around is representing the force of attraction between the ball and the earth. So remember this thing, that how you are representing this, you are showing this field or the field line, you are using field lines or arrows. So where the field lines will be congested, you will say that the field strength is high, and where they are scattered, you can say that the strength is not that high, or the gravitational field strength is low. As far as this point is concerned, the first point we can mention here, that the direction of the gravitational field is represented by the gravitational field lines. Again, as I have drawn here, these basically are the arrows towards the body. So whether you have the earth or any mass, you can say that the gravitational field is represented by the gravitational field lines. So this is the first point you have to remember. The second point is the gravitational field lines are arrows towards the center of the mass of the body. So not only the earth but any body which you can say has a field around, which is the gravitational field, is represented by arrows towards the center of the mass of the body. So this is something which is very important. And in the continuation we can determine another point, that the gravitational field lines are radially inwards for a point mass. Here remember one thing, that what is the point mass, we will discuss this in detail, but for the time being I'm just telling you that point mass, we can consider any body as a point mass if the mass of the body is small as compared to the distance of the bodies. And suppose if you have earth and moon, then the masses are big masses, but as the distance between these two is a big distance, so we can say that these two are acting as a point mass. So here these lines are radially inwards, and they are coming in this way, that they are indicating towards the center of the, suppose, earth or the moon, whatever, but they are radially inwards. So this is very important. Fourth point is just telling us that what this radially inverted field shows. So radially inverse gravitational field lines represent a non-uniform gravitational field. So this is very important thing. Non-uniform, as I have just described this fact, that if suppose you are close somewhere here, all these lines are giving you the gravitational field lines, and suppose you are close somewhere here, then a number of lines passing through this surface or this body, you can see, are more in number as compared to the situation that you have the same body somewhere here. If you have the same body somewhere here, then only you can see that 2 or 3 lines are passing. So the number of lines passing through a body are not same, and this type of situation shows that we are dealing with the non-uniform gravitational field. So this is very, very important. If you are considering a surface or part of the earth surface, then from a long distance you can say the lines are coming radially, but if you will consider only the part of the surface, then you will see that these lines are parallel to each other. So these parallel lines are showing that whether you are keeping your body somewhere here or somewhere here, or here, you can say, the position changes does not affect the gravitational field strength on this surface. So when we have this type of situation, simply we can say that we are dealing with the uniform field or uniform gravitational field. And as I said, that to represent these uniform gravitational field, what we have parallel lines. For a uniform gravitational field where the field strength is the same at all points, gravitational field lines are represented by equally spaced parallel lines, yani basically arrows. So this is very, very important to understand that these arrows will be parallel when you will consider the uniform field, uniform gravitational field. But when the field is non-uniform, the field will be radially inwards, or you can say that the lines are radially inverse. So these are few points we have to remember, and inshallah we will be continue with this discussion. Here I have been showing you the syllabus as well, and you must remember that you have certain points, specific points, or you can say learning outcomes. So you have to learn those learning outcomes, and inshallah in the coming discussion, in the coming lectures, we will discuss all these points one by one. So this is the first lecture of this chapter number 13 of A2, and this is the gravitational fields. Chapter name is gravitational field. Okay, so if you are new on my channel, so just share and like and subscribe this channel, and press the icon of the bell, so new uploaded lectures or videos you can see. And if you will follow these lecture series, inshallah, you will need not to go anywhere else, and you can pass your exam very easily and with the good grades. So till the next lecture, Allah Hafiz, take care.